In the past, I have said when you're building a crystal radio, the most important thing to make sure you have is a 1N34A diode. And yeah, being naive, it never occurred to me that a lot of these things you're ordering off the internet are fake. Yeah, they're passing these germanium Schottky diodes off as 1N34As. And you may say, okay, what's the difference? There's a lot of good videos out there about how to tell the difference. But what we want is we want something where we can check them with a simple measurement. It's like telling the difference between a rhinoceros and an elephant. I don't need to do a DNA test. I don't need to spend thousands of dollars on equipment. All I need to do is look at a photograph and say, okay, the elephant has a trunk and the rhinoceros doesn't. So that's what we're looking at here. We're looking at one simple thing that anybody can test. So if you have a decent digital meter and a battery, that's all you need. So what we're going to do is we're going to take the black stripe and we're going to run that to the positive side of the battery, and then the negative side of the battery goes through the meter. Got the meter set on microamps here, and a good 1N34A should have a little bit of reverse leakage. Now you may say, wait a minute, reverse leakage is a bad thing. So here it's showing about 1.7, 1.8 microamps. Reverse leakage is a bad thing, right? Well, no, not really. Again, what we're doing is we're just looking at one attribute that we can tell the difference between the elephant and the rhinoceros by looking at the trunk. A true 1N34A has reverse leakage. This was built for analog radio signals, and yeah, so it's going to have different properties than a Schottky diode. Now a Schottky diode, I don't know if you can see this, I'll put a close-up there. This has a green band on it, and we'll put that towards the positive. Now a Schottky diode is from the digital age, and it is meant to have no backflow. It's meant to be terribly efficient. But a lot of the other properties, like the difference between the rhinoceros and the elephant, a lot of the other properties aren't the same. So yeah, I can't put my fingers in here because that will distort the reading. But as you can see, it's got zero backflow on the amps. And that tells me that this is not a 1N34A diode. Yeah. So what I did is I got on the internet, and to save you a lot of trouble, I started ordering these things, and they're supposed to all be 1N34As. I ordered, you can see these packages over here. This one has the green band, this one has the black band, and I got 3 more packages, and they're all this, either the green or the black band, and they all test like this one. Yeah, so these are most likely Schottky diodes. And will they work? Well, there is a gentleman who put these through the test using a, we call it signal generator, and sent a sine wave through it. And when a sine wave goes through a Schottky diode, it comes out as a square wave. And when you run a sine wave through a 1N34A, it comes out as a sine wave. And that's what it's supposed to do. You're working with analog signals with a crystal radio, and you want to get an analog, a pure analog wave back out of it. You don't want it distorted. Okay, so that's it. I mean, if you're going to build a crystal radio, you need actual 1N34As. You can't just trust what somebody's saying because, frankly, they're selling bad parts. You can do the test on it. They're not very expensive. If you order some that are fakes, you know, throw them away. But this one actually says 1N34A on it. I got it, oh gosh, this thing is really old. It's probably 40 years old before the internet was a thing. And it's, yeah, it's marked, and so I know it's a actual 1N34A. Okay, so that was it. When you're building crystal radios, you need to actually make sure that you've got a real live 1N34A and not one of these fake Schottky diodes. Okay, so hope that's useful in your crystal radio design and building.